Cool. So, hi, Abdullah. I'm sorry if I don't pronounce your name well. So
No, that's
sorry.
all right. That's all right.
Oh, cool.
I'm good.
Hel-
I'm good.
Thank you for joining in.
Okay, thank you.
Hello, Archibald. Is it Archibald or Archibald?
Hello. It's actually Ashbound.
Archibald.
Yes.
Cool. Hello. Thank you for joining in. Hello, Tony.
Hi, I'm good. How are you?
I'm doing great. Thank you for joining in.
Thank you for having us.
Hello, Rufus.
Hello, everyone.
Hello, Alex. Hi. Thank you for joining in. Cool. So let's get to business. So today's session is about Lacuna Masakhane, parts of speech classification challenge. So we are supposed to classify parts of speech in Luo and Setswana. And my goal today is helping you guys build an end-to-end pipeline using Hugging Face transformers. So I hope everyone has gone through the information here. The error metric for this competition is accuracy. So we are going for each word, we are going to classify it into 17, either of the 17 parts of speech for both Luo and Setswana. And also they have a rule here that they have said it is important that only one solution be built for both languages, as this is a step in creating a solution that can be applied to many different languages instead of having to create a model for each language. So that's another key thing to pay attention to. So I'm not going to reverse engineer everything. There's a pretty cool discussion here from what's his name? Let me find him. Yeah, Kenyor. So he created for us a starter notebook already for converting the data into CSV. So we are going to use his code. And please upvote for him, because that's a very cool discussion. So he created a script to convert the data into a CSV file. So actually we are going to, and I hope you guys are following with me, so that will be cool. So we are going to run his notebook. First, you're going to utilize GPU. So make sure you turn on your GPU. Then we are going to run his notebook. Yeah, up to git clone. So we are not going to do all this other stuff because his fork, this GitHub here. Yeah, this GitHub here has created also he forked this repo, this main repo. I guess this is his forked repo. Yeah, this is the original repo. I want his fork. What? Oh, no. I want okay. So his fork has, so when you git clone this repo, the MasakhAPOS folder or directory will appear in the contents, Google Colab contents parts. Then you navigate to data, and we have this African language.csv. He's the this file here he created is the file he created. So we are not going to run everything. So we are just going to use this file path. So we are going to delete all this stuff here. This. We don't need all that. Nice. So we just remain in the git clone parts. Then we are going to install some dependencies. So pip install transformers, pip install. Let's see. What else do we need? Pip install datasets. Do we need datasets really? Okay, let's just install it. Yeah, pip install datasets. Pip install. What else do we need to pip install? Pip install accelerate. Pip install accelerate updates. So thanks for those who have joined us. We are solving Lacuna, this project here. So if you have not taken a look at it, so please do. I'm not going to explain all this stuff. I'm just trying to show you guys how to build an end-to-end pipeline using Hugging Face. Nice. So next thing, and please, if you have a question, interrupt me and ask me. Yeah. Imports libraries which we are going to use. So import pandas. Most of the time these things we copy and paste, but since it's a live session, I'm going to do everything from scratch because I'm assuming you guys are following with me. So we need pandas, we need, do we need NumPy? Okay, these import NumPy as NP. What else? Do we need Seaborn? We don't need Seaborn today. Do we need Matplotlib? We don't need Matplotlib today because we are not doing any EDA. So I'm going to install only things I need. So from sklearn, that's model selection, import train test splits. From sklearn.metrics, import accuracy score, because our evaluation metric is accuracy, but you can extend this. You can also add your additional metrics to see how the model generalizes across different metrics. So we also need S for our directories to join the directories, to access the directories. We need touch from datasets, import dataset dicts. I want to use this dataset dicts. Yeah, will I use dataset? Let's just put it. Then from transformers, import auto tokenizer. Then what auto model for sequence classification, and also training arguments. I'll explain all this as we go on. It will start to make sense, all these things we are importing. Then we need then you can if you guys know 1DB, do you guys know 1DB? 1DB is to track your experiments. So you need to have an account already. Then you log in. You get an API key which you'll use, but you're going to see all that. Import 1DB. Cool. And now you're done with the imports. Maybe I've not here. Pip install 1DB. Pip install 1DB. Cool. As they keep on installing, do you guys know 1DB? 1DB.
Yeah. I know it.
Yeah, cool. So we are going to use it to track our experiments. Super cool. If you've never heard of it, please check it out. Also, today I'm not going to talk about the fundamental NLP stuff that you can read for yourself. I'll paste a very important link here. It's a notebook in Kaggle called, was it Kaggle NL? Yeah, I guess it's okay. I really don't know. There's one which goes into details about NLP. Yeah, it's this notebook. Talks about everything. Turning the vector. Okay, not this. There's a better one, which goes into details. It was called knowledge. Yeah, knowledge graph and NLP tutorial. Yeah, I think it's this. So this talks about NLP, knowledge graphs, talks about the attention mechanisms that power transformers. So you should check it out. It's cool. Yeah, it talks about bats. So if you want to get in a deeper understanding, here's the link. You can check it out. Nice. So we import our libraries. From SQL line import accuracy. Cannot import. Okay, typo. Then it's good practice to set. It's good practice to set most of your parameters globally. So configs. Okay, setting up your config setup. So this will store the paths. It will store the most of the things you want to like. You don't want to type in it every time. So class CFG. Then we want to track test path. By test path, it's the test.csv. You want to track the train path. I set configs for test train. Also the model you are going to use. So model name we are going to use. Then device, obviously we are going to use the GPU. Seed. What else am I going to track? Max length. Number of classes. number of classes we know, so that's 17. How we know that? It's because, but you can also check in the data. There are 17 parts of speech for both Luo and Setswana, so that's 17. So dropouts, okay, that's complex stuff. Number of epochs. Then what else? What else? Label mappings. By label mappings, okay, I'll explain all this as we go on. So don't be afraid if you don't understand what this test path is. It's self-explanatory. So test path, we have this. We copy this path here. Then train, as we saw from this very cool starter notebook from Kenyar. Shout out to Kenyar. Give him upvotes stars on his GitHub because this is such a cool thing. Most people would have struggled to even start building their .csv file. Then model. So model, we go to our amazing Hugging Face and search for models. So before we start, this is a multilingual task, okay? So multilingual task, by multilingual, I mean you have to find models that are trained using other languages other than English. The best models is those trained on African languages. So you have to go to Hugging Face, search Hugging Face models. It will take you to a repository, let me call it a repository of models. Then search multilingual. You'll get a lot of models which end with multilingual. Then try to find one which was trained on African languages. Or okay, for our task we are going to choose BAT-based, multilingual, and cached. So there's a lot. So let me show you guys. Let me show you guys one of the best models trained on African languages. And this you're going to try it for yourself. Don't take my word for it. It's called Davlan. It's trained by Davlan. Davlan is a yeah. Davlan. Davlan is a guy. Davlan is a guy. Shout out to him. He has done a lot of cool stuff on African NLP space. So shout out to him. So you can search for models here. For example, this was trained Arabic, German. So this is not trained in African language. I guess Afro-Excel. Yeah. So this was trained in African languages. We have Hausa, Igbo, Luo. We have even for Luo. So this could be okay. Let's use this. Let's use this for a starter notebook. So model, Davlan, device. Device is GPU. So touch device. It's either you're using GPU or not, or CPU. So if touch.cuda is available, else CPU. Seed, pick your lucky number. Mine is always 42, which is for like almost for everyone. Yeah, we need to import touch. Touch.device coder, if touch.coder is available. Yeah, pretty sure that will work. So maximum length. So let me find you the best explanation for maximum length. Maximum length is how many token, it's the token length a model can support. So maximum length in regards to bars. Yeah, so maximum length specifies the length of the tokenized text. By default, BAT performs word-based tokenization. For example, the word linker, display, blah, blah, blah. So read about maximum length. For BATs, so different models have a way of splitting texts. BAT does word-based tokenization. You can search how does Roberta do this. So for maximum length, also maximum length, it depends on your data set, because currently here, okay, we've not even loaded the data, but so let's default for 512. Then we are going to change that. We're going to change that later. Number of epochs. Since this data was already trained on African languages, you don't need to like train it for a lot of epochs because it will overfit. So either choose 2, 3, or 1. For us, we are going to choose, okay, let's choose 2. But yeah, let's choose 2. Label mappings is what we are going to get when we dictify the labels. And we are going to see that. So at the moment, it's done. So we set up our initial config. Then next, we set up 1db. 1db. Set up 1db. So 1db.login. First, you need to have an account. So you need to log in, set up an account on 1db. It's pretty easy. You can even log in with your GitHub accounts. So it depends on you. So also we want to keep a track of the project name, which will be the name which 1db will save or use. So we are going to say baseline Lacuna trial 1. Yeah. Then we are going to, so you pass the configs into here. So that's the purpose of configs, to make your work easier and for reproducibility, like everything you want to change on your board, I'll do it on the config. But it depends on your preference. If you want to do it the way you like, do it. So this is not a standard. It's just it just makes your work easier, honestly. So we log into 1db. Going to take a while, not that long. So yeah, so it's going to ask for your API key. Click on that link, access your API. Paste it, and now you're good to go. CFG has no attribute project name. Project name around this. Cool. Nice. So we have our 1db setup. Now we want to log every trained model. So let's see how to do this. So 1db log model is equals to true. Then we are going to set up our random seed for reproducibility. So to avoid randomness and to make sure that our models scores are reproducible, you have to set up your random seed. Most of these things I copy and paste because they're just default. For example, this function for set random seed, it's pretty much the same. So you can search it, and then copy and paste it. It's the same. So, but I'm assuming we are coding together. So let's make it fun. Code everything. Random seed. Any questions? Any questions before we continue? As I type this,
Yes.
Okay, ask.
I joined late.
Yeah.
So I was wondering where you got the
Oh, so we have this discussion, pretty amazing, from Kenyor. Where is it? Yeah, converting data folders to single CSV file. So when you go to this, first you upvote because it's such a cool thing he has done for the community. Then you go to this notebook here, Collab. When you go to this notebook, you'll find an already set up data set. So you just use it. So you git clone it, then you get rid of all this other code because he has already done it. No need to reverse engineer what he has done. Then when you git clone, so actually we git cloned, then the data will appear at the content sections of Google Colab. Then the only data we are interested in is this africanlearn.csv and test.csv. So you just set up your path here, then we continue.
Okay.
Cool.
Thank you.
Cool. So let's set up our random seed code. So, nice, that's already set up. So you're going to import random. NumPy has no random.seed. Random.seed. Cool. So we have set up our seed. So let's comment this for reproducibility. Nice. Now we load the data sets. So train is equals to pd.read csv cfg.trainpub. Display. Nice. Now we have our train sets, we have our test sets, word, ID word, language, part of speech. Nice. Train.shape, test.shape. Uh, 654,842 words. That's 2,045 in test. Cool. Also 17 to confirm the 17 targets. So train his target tag dot n unique. So here, number of classes at first should be none. If you don't know, if you're not sure, or if you want to be safe enough, then here you set up your config num classes based on your train set. So cool. Now, since before it was none, but now it's 17. Cool. And so after loading the data set, you can do a lot. You can find how the words have been distributed across different languages. So value counts. So you can display train. No, language value counts. And then we also want to see the target value counts. Yeah. Nice. So you have languages, they're not even, not imbalanced. The distribution is pretty okay. Oh, here we have to change this to targets. For this is a bit imbalanced. For X, SIM, int J. Then you need to know also, there's some here, noun, verb, punctuation. You need to know what all those abbreviations stand for. Cool. So yeah, you can do a lot. You can do it on yourself. But since this is a modeling pipeline, let's continue. But you can do a lot. You can do a lot. So next thing we are going to do is find the label mapping. So we want to transform these targets to numerical values. Hugging Face has its own way of doing this. I don't know, it's called num to labels, a function called num to labels, but we are going to do it manually. So find label mappings. So first we're going to rename the targets. Scene dot rename. A label, then we are going to find we're going to use did we import? No, we never did. So we're going to use label encoder. So from sklearn.preprocessing, import label encoder. Then train label fit. Nice. Then we get the mappings. So how we do this is CFG. Remember we initialized it to none in our config. So we have to change that. Is equals to dict zip the left dot classes and lay dot, what was the other one? Transform lay dot classes. Nice. So then we can print the CFG dot label mappings. Cool. So now we have a dictionary with the original target and its key and its value, key value as the int equivalent of the target. Cool. So after that, do we need to do anything else? Now we do. So we first set up our model. Then we are going to set up our data sets, etc. So you can do it either way. You can start with the data set, but let's start with the model. Tox is equals tox is a tokenizer. What does a tokenizer do? Here. BAT performs word piece tokenization. Now this tokenizer is the one which performs this tokenization. So, and remember we said each model family has its own way of performing tokenization. I guess, but for BAT is different from Roberta. So, but Hugging Face has provided a very cool workaround for that using auto model. So when you're using auto model, you don't need to worry about different tokenizers because auto model will handle that for you based on the model you have passed. Remember this model we initialized here. So the tokenizer for this model will be used. So for Davlan, the Afro XLMR mini something. So it will be used. So cool. Then model is equals to, now we have initialized the tokenizer. Now the model, auto model for sequence classification. That from pre-trained. cfg.model name and num labels. Num labels is equals to cfg dot number of classes. Then there's some other additional parameters like dropout. If you want to use dropout, you can add dropouts to these arguments here, but you're not going to use dropouts. If you want to experiment using dropouts, please do. Then cfg.device, push it to GPU, push the model to GPU. Then cool, we have initialized our model and tokenizer. Nice. Now we set up our data sets. And Hugging Face is fun, and it has made some of the things which you are doing in PyTorch so easy. But if you want to have total control of what your pipeline and model is doing, you can use all other frameworks like Torch, TensorFlow. Yeah, Hugging Face has made things easier though. So you have options to choose. But yeah, I'm showing you Hugging Face because it's the easiest for anyone to understand. So yeah, so setting up our data sets. Here, what we want to do is we want to have our training, valid, and test. And this, you have to do it very careful. I know most of these guys, okay, I don't want to assume, maybe people are too good, but most of the time people use 10 task splits just because it's the most popular like validation scheme. But remember here, we are performing validation on unseen languages. So training set has different languages from the test sets. So you have to handle that in your cross validation. If you use 10 test split, you'll have both same languages in train and in valid, which you don't want. You want your valid data set to have unseen languages so that you can see how your model is generalizing across unseen languages, right? Cool. With that being said, how are we going to handle this? So here, so there are a lot of different languages, as you have seen here. We have Igbo, Fon, Wal, Yoruba, Hausa, Twi, Swahili. So, and the validation and the test set has Luo and Setswana. For Setswana, it's easy because you will find all the other Bantu languages in South Africa and use one of them or multiple for validation. But for Luo, it's so difficult because all these other languages that have been provided here are all Bantu speaking. The difference is where the location, blah, blah, blah. But all these other guys up here are Bantus. But for Luo, we don't have any other Nilotic speaker in these languages. And that's the pain point of this competition. So you have to find a language that is different, far much different than the rest, then use that as another Bantu language in your cross validation to see how it will generalize both for Setswana and Luo. Doing that is so difficult, but we're going to just pick randomly. So for this, you add another config here for valid languages, which you want to be in the valid set. So we are going to use, let's pick a random one. Type in the charts. Type in the chat so that I know what you guys want to use. Which languages do you want to use as a valid language, which is different? So I've explained why we need to have different languages in the valid set. for our model to generalize better. So, anyone type any languages too. You can use two for validation. For in your case, when you go to experiment further, you can use other languages. So let's see. Wolof, cool. Wolof. Okay, so we have people from different backgrounds here. Do you have people from South Africa? They can tell us Setswana is related to which language, so that we put that in the valid languages. Yeah, but you can use Wolof and another one last one. One last one. Are you guys afraid to talk, or let's have fun? We are here to have fun. So please. Wolof, Susu. Susu, is that Susu? I don't think there's Susu. So we have Wolof here. We don't have Susu. We have Swahili though, and we have Shona. Shona might be closely related to Setswana, but I'm not sure. I wish people from those speaking languages were in the live or in this webinar. They could have helped. Anyways, let's choose Wolof and Swahili. Someone has typed. Yes, let's do Shona. Cool. So we are going to use Wolof and Shona. So Wolof and Shona. Nice. So Wolof and Shona. Cool. When we do this, nice. We're going to run everything because we have other CFGs that we have initialized as we are going on. So not to have any conflicts. Setting up our dataset. Now that we have the valid languages, now we can do this. So, okay, cool. Their valid is equals to train. What's the name of that? Lang dots is in CFG dot valid languages, and then drop columns is equals to. So we're going to drop columns which we don't want anymore, like language. We don't want language because we've already determined what we want in our valid sets. Yeah, that will work. Df train is equals to now the opposites. So train, just copy and paste all this. Then put our, I don't know what that is called. So yeah. Then, so yeah, DF test, our DF test is the test data sets, but with only the word. We don't want the language, so we want inputs and labels. So word and label, really. Okay, so no, we don't want the label. We want word. Yeah. Yeah. Cool. So word. Nice. Now you have your DF train, DF valid, and DF tests. So df train dot shape, df valid dot shape, and df test dot shape. Cool. So our train now has 571,000 versus 83,000 invalid versus df test. That's a pretty good split. So yeah, cool. So now, we can also check how good our split is. So df train dot label dot mean versus df valid dot targets or dot label dot mean. Yeah, it's 8.44 versus 8.26. I can arguably close. So the split is cool. So then next we want to, because Hugging Face expects a dataset dict. So we have to turn this pandas data frame into a dataset dict. Remember the dataset dict we got here from datasets? Hugging Face expects that. So we're going to create our own dataset dict. So we're going to call it just a random name. So Masakhane dataset dict. Now we are going to have train, we are going to have valid, we're going to have test. So these are the keys. And the values are the data frame themselves. So data set from pandas. Data set that from pandas. And we have df train. Df valid is df test. Df valid. Masakhane. Let's see how it looks. Cool. Now we have train dataset, features, word label, index, valid dataset. You can drop this index level here, but that won't affect our model. So features, word, numbers, cool. Now we go to tokenization. As I had said, different models have different tokenization schemes. So you can read about tokenization. What is tokenization? So in layman's language, in the simplest way possible, you have a word like basketball. So basketball can be tokenized in some models can be tokenized as one language, but in others it can be tokenized to basket and ball. And yeah, so basically breaking words into tokens, tokenization. But you need to go and study. Remember the link I just pasted for you guys. Go read that notebook. It has all explanations. So yeah, that's the simplest way I can explain tokenization to you. Basketball, break it down to basket and ball. Cool. So now we have to perform tokenization for all these datasets that are in the dataset dict. And we are going to do this using .map. So we have to, we create a function. And most of these things are pretty default. So most of the time, if you've already done a similar NLP problem, most of these functions are reusable code. So most of the time, you find yourself just copy pasting a lot of things. So, but let's just code it. padding is equals to true. So truncation, if our, so what truncation is, so let's rethink about our max length. We never really thought about it. Okay, so most of these are words. You will not find any word that has surpassed that is 512 in length. That is not going to, that is impossible in this data set, because you're dealing with words that are part of speech. I don't think if there is a part of speech that has a sentence in it, I don't think so. So in most cases, you can find it, you can find the character counts and find the maximum length, but I don't think even 20 is a bit more. 20 is a bit more, but to be on the safe side, you can calculate the character count on yourself, then replace the maximum length here. So 512, we are overthinking. So let's put it at 50. I don't think there's a word that is longer than 50 in any language. So okay, my assumptions too. You're going to find the character count and see which is the longest word in this data set. But honestly, I've done it, so there's no need for you guys to do it. The longest is 38. So yeah, maximum length is 30 to 38. The longest word in this data set is 38. Then what truncation does, if there was a word which is longer than 38, it will be truncated to 38. What padding does, if there is a word which is less than 38 max length, it will be padded with the zeros to be on the same like length. So if a word has 12 max length of 12, it will be padded with zeros until it gets to 38. But if you had a word that is 50 in length, it will be truncated to 38. Yeah, that's the simplest explanation I can tell you about truncation and padding. But you have to go and look for the correct explanations. So our max length is equals to CFG dot max length, which we initialized. Okay, so we're going to replace, since at first, and I don't want to rerun the notebook again, you can override the max length is equals to 38. But in the notebook, which I'll post on my GitHub, it will have the initial max length to 38. So no need to do this. And then we encode it. We encode the Masakhane dataset. So Masakhane encoded is equals to Masakhane dot map. Now we map this function, tokenize, then batched, set it to true. You can also pass batch size, but to use the batch size. Okay, but I don't think it's necessary. But yeah, you can pass it. So it uses the batch size you initialized at the start to do all this. Did we even have batch size? Did he have batch size though? Yeah, we never had batch size. So batch size, we're going to use, since these are words, we're going to use 256. I hope Kuda will not misbehave. So 256, and since we had not initialized earlier, okay, we're going to just rerun all this so that I don't confuse you guys, because at the end of it, I'll end up deleting that. So let's do it in the correct way. So CFG, where is our CFG? We're going to run this, then run everything else. Yeah. So here it is tokenize all our. Okay, we're going to find an error though. Yeah, we're going to find an error. We're going to find an error because we don't have, oh no, this is not the error I was expecting. Yeah, we're going to tokenize the word. This is not the error I was expecting. It's an error. Yeah, text encode input must be union. This is the error I was expecting. This means, and it took me a long time to debug this. This means our train dataset had nulls. Okay, has nulls. So if you look at train dot is null dot sum, yeah, we have nulls, 211 nulls. So we are going to drop the nulls before we encode our data sets. So where is the best place to do this while we are renaming? Yeah. So train is equal to train dot drop now. And now it will run. Cool. Now we have done the tokenization. And I guess that's it. That's the only preprocessing you need to do. The next thing you want to do is now modeling. Pretty simple, right? We have just loaded our data sets, preprocessed our data sets, put them in the right way which Hugging Face expects, then tokenized it. See, it's successful now. Now we are going to set up our training arguments. Training arguments. So model name is equals to model, not even model. So we already have a model name. So what we want is the model we initialized in our configs name. Then, yeah. Because this is not the model exactly, this is the model name we want to save our model with. Yeah, the output directory we want to. So yeah, this is just a random name. So model name, you can name it anything. Masakhane challenge. So I'm going to show you where we are using this model name. So training args is equals to the, remember the training arguments we imported from transformers. We are going to use that training arguments. Output directory. Output directory is equals to model name. That's why we are using the model name. So yeah, then we want epochs. Num-train epochs is the epochs we initialized in our configs, which is cfg dot num epochs. Num epochs, yeah. Then learning rates, but you can use the default too. So learning rates, we can set it. Also, this learning rate is supposed to be up there with the configs because you want to change everything before you start, so that experiments might be easier. So we are going to use to E05, but make sure you, in the configs, you add it yourself. Yeah, so linear LR scheduler type. Okay, all these other things you can use. If you want to go deep, yeah, you can go deep in the other training arguments to change, see if it makes your models better. But what I want is, because based on my experiments, I've seen that most of these models overfit pretty easily. You train in around, even one epoch has not ended, but it has already started to overfit because most of these language models, as we have known, as you have noticed, have been trained on African languages. So most of the time they overfit pretty quick. So we want our evaluation strategy not to be epochs, but steps. And you'll see this as we continue. Why it's important? Because why it's important? Why I'm using steps is because our models overfit pretty quickly. So we want evaluation strategy to be steps so that we can save our best model using steps, not epochs. So evaluation strategy steps, save strategy should also be steps. And yeah, save strategy. All these training arguments are in trainer. If you look at trainer, Hugging Face, it has all these arguments. So you can just check it out. Just check it out. Just check it out and see all the available parameters you have for you to change. So save strategy, we want it to be steps. Nice. Also, we don't, okay, this is based on my experiments. The save steps are for me personally, I use 10. I use 10 and eval steps I also use 10. And you'll see why, because if you run this for a lot of steps, like if you want to save your model based on 100 steps, before that 100 steps reaches and the model starts to overfit, it's like early stopping rounds, the way it works. Before it reaches that 100, it has overfitted like completely. So you want to have minimal steps that even when the model overfits, you get a good model as close to the best model. Yeah, if that makes sense. And it will make sense when you start seeing the training logs. And yeah, also since we are using 1DB, we have to add another argument here, report to 1DB. Cool. I don't know why this is giving me an error though. Save strategy. Save strategy is not defined. Okay. What is it called? Save strategy. I'm pretty sure that's what it's called. Save strategy. Yeah, I'm pretty sure that's what it's called. Save steps. Yeah. Yeah. Report to 1DB. Report to 1DB. And what other argument do we need? Oh, yeah. The metric we want to use for best model. So metric for best model. Metric for best model is equals to, so we're going to use accuracy, but you can use eval loss, you can use the F1 score, but since the evaluation strategy for us is accuracy, we are going to use accuracy. I don't think if there's okay, there are many arguments you can change, but as for now, let's stick with this. So I hope it, yeah, pretty cool, nice. Now we have our training arguments. Another thing we want to do is we want to create a function to calculate the metrics, then pass it to our trainer. So compute metrics. Also this, it's in the documentation for Hugging Face. You can just go and copy paste it, but okay, I'm not tired yet, so let's just type it. So compute metrics eval pred. So what you want is predictions, labels, and preds Accuracy, if you want F1 score, yeah, you can add F1. Cool. So predictions, no predictions, labels is equals to eval pred. Then preds is equals to np.argmax predictions. Axis is equals to 1. Nice. Then F1 micro is equals to F1 school. Labels, predictions, average is equals to micro. Yeah, and the macro is average is macro. You can even add precision, you can add recall. Yeah, depends if you want to see how good your model performs across different metrics. So for now, we are going to stick with those three. So labels, spreads, return, then you return accuracy. Now this will be the one to track our best model. So accuracy, then F1 micro. Nice. F1 micro, F1 micro, then F1 macro, F1, F1 macro is equals to F1 macro. So this is F1 micro. Yeah, I want to make sure this is correct before I continue because the effect of this will be felt after training in our first steps, 10 steps. So, and training takes a lot of time. So yeah, I think it's okay. It's okay. Nice. Cool. Now training. Now we are going to the cool stuff where people love seeing your model improve. So training. So we have, it's pretty easy. So initialize a trainer, then it takes in model is equals to the model, which initialized up there, then compute metrics or args. Yeah, training args. This training args we just wrote up here. Then metrics, compute metrics, is equals to the function we just created, so compute metrics. Yeah. What else do we need? The train data sets. And this, you want to use the data set we encoded. So remember the Masakhane encoded data set, train. Yeah. Also, you want the eval data set. So sorry. Come on, man. Eval datasets. Masakhane encoded eval. Valid. Yeah, we call it valid. Then tokenizer is equals to toks. Then if you had a callback for early stopping, you can add early stopping, and it's simple to add early stopping. Okay, let me just show you guys. So we have to import it. Did we? We never did. So we have to import the callback from transformers. Yeah, so early stopping callback. Should we? Yeah, let's just, it's not a lot of work to set it up. So early stopping callback. But you have to initialize the config again. Okay, no. So I just do it manually, then you can go correct that based on your runs. Yeah, so early stopping callback. So what we want is patience. How many steps do you want to wait? Because now we are using steps, not epochs. How many steps do you want to wait without without improvements? Do you want to like stop the training? So early stopping callback actually comes in handy here, because as I said earlier, this model overfits pretty quick. So if you're waiting, if you have set up 4 epochs, and as much as we have used a batch size of 256, it takes a huge amount of time to train. So without early stopping callback, you're going to waste your whole day in an overfitting model. So it's good. So you don't have early stopping patience in CFG. So let's give it 50 steps. Yeah, 50 steps. You can change that as you continue. So callbacks is equals to early stopping callback. Yeah, and that's it. And we are cool now to train. I hope it trains with no error. It's hard to get it right in the first time. So train out or train. I hope it works. I hope it works. Early stopping callback requires load best model attend is equals to 2. Yeah. So just copy that, put it here in the training args. Yeah. Cool. And we are training, I hope. Let's go. Yeah, we are training. So as I had said earlier, the steps, eval steps 10. See, it has just trained for 10 steps, then it just started evaluating. So that's the essence of steps. If you had set it to epoch, you could have waited for this here to turn to one epoch. And before you get to 1, maybe your model could have overfitted. So, okay, let's wait. Any questions? Any questions before I go to the isn't there a way of finding the best parameter automatically like grid search? There is. I don't know. I've never used grid search so extensively, but I've used Optuna. So search Optuna and how to use Optuna with Hugging Face. Then you can tune the parameters. Cool. Any other question? Are you guys following? I hope you're coding with me. No worries. Any other questions? Cool. So our model is validating. So let's create our inference pipeline as it continues, because it's gonna. Okay, let's just wait to see how it performs in the first run. It has trained only for 10 steps, and you'll see how good or bad it is. But okay, let's continue to the inference pipeline. You can just to see if your config is working, early stopping is working. When early stopping finishes, then you run trainer.evaluate. You should not see the model that is at the last when the model stops training. You should see your best model. You should see your best model. So that's one way of troubleshooting your early stopping callback to see if it works. So you can run it after trainer has trained and see if your early stopping callback works. Yeah, so we are going to set up an inference pipeline. Okay, see here, this is very easy to forget, right? That's why you need, that's the importance of CFG, the config we set up above there. So in your runs, when I post this notebook on my GitHub, just go download it, run, but set this, everything that needs to be changed, like patience should be up here in the config. Then learning rate, save steps, eval steps, all these should be up there in the config, so that you don't need to, like, when you start, like, maybe you can forget to set it up later. So, or you can do it your way. Either way works. So yeah, cool. So nice. So you're going to see no log for a while. This is because it uses warm up while training. So it warm ups, then for a while, then you'll start seeing the training loss later as the training continues. So our first accuracy is 0.18. 0.18, it will keep on improving. Let's leave it and let's continue with the inference pipeline. So one clever way to do this is, because this takes a while to train, and if your runtime ends before you perform inference, then that will be a problem. You have to retrain it again. So to be and the way Colab like limits us with the training hours. So let's save this model. Let's save this model. Trainer.save model. If you have the data in your Google Colab, you can save this model in your Google Colab in a very easy way. When you save it like this, you'll save it in contents. Then you can download it later, upload it to your Google Colab. It will be too much work. So set up your your data in your Google Drive, then just save this model in your Google Drive. Yeah, so we are going to save this. Okay, baseline model. Then when you have your saved model, it's pretty easy. You can create another notebook for inference separately, but I'm not going to do that. What I'm going to do is I'm going to set up an inference pipeline right here, but you can separate it if you want. Depends on your flow, depends on what you love, what you are used to. So a lot of things are gonna copy paste. So from transformers, we need NumPy and we need torch. So transformer, all these, just copy paste all these, except 1db, obviously, because 1db, we are finished with 1db. Yeah, when you run this, trainer.evaluate, yeah, you can finish your 1db experiments, because 1db doesn't like, you don't want to use 1db in inference, because what are you recording in inference? So you can finish your 1db experiments right there. Then copy, paste all this other stuff here. Get rid of 1db. Get rid of datasets. Get rid of all this. Get rid of all this, except NumPy. Pandas. Yeah, we need pandas. OS, we need OS. Do we need random? Doesn't hurt to leave them there. So import touch, import transformers. From transformers, yeah. Cool. So I don't want to run this. Okay, yeah, let's just set it up for the time being as our model trains. We are going to interrupt the training so that we can make our first admission. As long as you have understood the flow, then that is what that matters. You just call trainer.train, trainer.evaluate to confirm it. The trainer.evaluate part is not very important because you're going to see the evaluation metrics while training. So evaluate is just to confirm if your early stopping callback is working. So yeah, then you save the model. Then here we reload them. Next, what you want, since you've saved the model, you want to reload. You want to reload your model. So how we are going to do this is, it's actually simple. It's nothing Hugging Face has made everything so simple. I love Hugging Face, man. Auto model for sequence classification. And we are going to talk about why we are using auto sequence classification instead of token classification. So yeah, from pre-trained. So our model will be saved here in this content, here. It will come below 1 dB. So just I think the path for content is the path for content. The path for content is content. Yeah, I guess so. Let's confirm. Copy path, paste it here. Yeah, it's content. And now it will have the name we passed here, baseline model. So baseline model. Cool. Then you don't want to forget the num labels because that is important. Num labels is equals to CFG dot number of classes, which is 17. Right. So what else? Just that. Then the same way I've loaded our model, we load our tokenizer. Loaded tokenizer. Is equals to auto tokenizer. Auto tokenizer from pre-trained. So working path the same, contents. Then baseline model. Cool. Now we have loaded model, we have loaded the tokenizer. The only remaining thing is to perform inference. So we are going to set up a training argument specifically for testing, because it's different from the one which you used for training, because now you don't have compute metrics. So just a minute. Any questions? Any questions? Any questions? Any questions? So our model is running. The best accuracy you have is 0.27. Fair enough. Cool. Test args. Now my mind is tired. Test args. So it's just the same, but with some little changes. So training arguments, output DR. So we're just gonna put all these output out in content anyways. So output DR, then do train is equals to false. These are the new arguments. Then do eval. Is it eval? No, we're not evaluating, we are predicting. So do predict is equals to true. And per device, do you need per device though? Data loader job last. Okay. Is equals to false. Let data loader drop last is equals to false. I don't even think that is important, but anyway. Trainer is equals to trainer with the args model. Now we are not using the original model, but we are using the loaded model. Loaded model. This is loaded here. So args, now we are not using the training arguments, we are using the test arguments. And do predict. Do predict. No. Yeah, just that. You don't want compute metrics because what are we computing? We are just predicting. So yeah, then actually done. Test results, we are actually done. So test results is equals to trainer dot predicts. Trainer dot predicts. Remember we had our encoded data sets, Masakhane data sets. No, Masakhane encoded, right? Test results, and we have our test results. Then these test results, we wanna create a sample submission file, right? So to create the sample, to create a submission file, we have to reverse the label mappings. Okay. Yeah. So prepare submission file. Prepare submission. Actually, okay, let's just do it. Results is equals to test result is equals to test results dot predictions dot argmax. Axis is equals to 1. Next, what you want to do is want to create a data frame, assign the test IDs to a sample submission file. Pretty easy. So result is equal to you can do this one liner though. PD dot data frame. Okay, it will not be clean enough. You want to understand most. I want it to be easily understandable. So result is equals to PD dot data frame. PD dot data frame result columns is equals to red, and results ID is equals to the test's ID. Then results, right? I think so. Yeah. Then now, since now the result will be numbers, so we cannot do all this step by step because this is still training. So we're going to have to wait. Let's not interrupt it. Let's wait for it to get to a good accuracy. Yeah. So results. Let's continue the up. Name is equals to. The reason we are reversing the key because it was not in the right way for mapping. So the value key for key and value in CFG dot label mappings. Our label mappings dictionary dot items. Then now result, we apply these namely mappings. So result red is equals to result red dot map name lay mapping. Then results dot head result.head. So name LE mappings is equals to value key for key value in result spread is equals to result spread of map result.head. Then submits baseline. That's CSV index is equals to false. Yeah, and we're done. We are done with our starter notebook. So I think we could have warm-up steps. Warm-up steps. So that is warm-up takes only 10 steps. Warm-up steps, 10 steps. But I think the default is 10 warm-up steps. Warm-up. Okay. So when we interrupt it right now, it will still have an accuracy of 0.2159. So let's just wait for it to reach 100 steps, then we interrupt it, then we submit that. Cool. Any questions? The pipeline is over. The only thing is remaining is for us to run the remaining cells, but we can't run it right now because it's still training. Or let's interrupt it. The main point of this was not to get cool scores, but to have an end-to-end pipeline. So right now, when I run trainer.evaluate, it will have this instead of this, because we never waited for early stopping to be invoked. So yeah. So yeah, we are going to wait for that, and then run all this, then make our first baseline.csv. Cool. Any question? Any question? Because we are about to end. We have finished the pipeline. So the next step will be trying to improve our model. So stick, and we'll see if we'll improve our model. Okay, any question? There was someone who wanted to talk, so please talk.
Oh, thank you very much. Please hear me.
Yeah, I can hear you say.
Yes. So, from the model that we have, I want to solve them from the data. I can show you where my question is from.
Oh, where? Sorry,
Like the notebook. I have to see the notebook so I can show you. Yeah. From this model, like, how will I be able to maybe if I want to the parameters you are showing, how you were going to see warm up table, how will I be able to know it? How will I be able to put those parameters that I want to change? Like if I want to add additional parameters to it, where will I go? Because I see you going somewhere in the whole phase, but I don't really understand
Oh, okay. Where you want to know? Oh, the question is, where do you find the additional parameters?
Yes.
So you're going to search on Google trainer parameters. It's on the Hugging Face though. So it's going to bring you here in trainer. Then you're going to come to these evaluate parameters right here. So these are a lot of parameters which you can check. So you're going to come here at Hugging Face, find trainer, then go through this documentation. So there's a lot of things you can do. You can create your own custom trainer. Then here is where our training arguments, where the other parameters I was talking about, you'll find. So this is for the trainer itself. Let me search for you the exact training arguments. That's the exact training arguments you're looking for. So no, not here. Yeah, there's a lot of parameters here, but I'm looking for the exact one you're looking for. Yeah, this is the exact one you're looking for. So it's on your right hand, on your right side of trainer. I'm not a web developer, so I don't know which is it called a section or what. It's on your right hand side. So training arguments. This is what you're looking for. So you have learning rates, you have weight decay, you have Adam, mark steps, LR scheduler, type, warm-up ratio, warm-up steps. Then you have also parameters for logging. Yeah, there's a lot of parameters here you can play with. So I hope that has answered your question.
Yes, it does.
Cool. So output directory, now we have a typo here. Yeah, so let's create our baseline. Then we try to improve our models. Our model score, currently we are at 0.21 accuracy. So we need to do better. So we're gonna wait. Any question, any other question as we wait for this prediction to end?
Sorry, please. Would this notebook will it be available to us? Like this
Yeah,
particular notebook?
yeah, for sure. So these sessions, live sessions with Koding with Kolesh, we have a GitHub repo on my profile. So every competition we go through, you'll always find the notebook there. So you go to my profile, I'll link it here on the charts. Then go to challenges. Currently, I've not uploaded for Lacuna, but that's going to be next. The past competition which we looked at was RMB, and you can see all the starter notebooks here. So everything we are going to do or go through is going to be available in this repo. So yeah.
Thank you.
Good. Also, yeah. Now we have, it's not maps though. That map, it's supposed to be mapped anyways. Results is equals to result. ID spread, namely mappings. So result spread is equal to result, because it's supposed to be working. Name early mappings. Oh, damn. What did we do here? It's not supposed to be like this. Train, turn. Label. Okay, we're going to do this again. So train path is not defined. Okay. Nice. This is what I want. So when I run this, it should be okay now. Cool. Get rid of this. I don't know where that happened. Okay. Oh, this was the keyboard interrupt. So we have our baseline here, baseline.csv. And we make our submission. Cool. So 0.2271. You can see they are closely related with our locally. So we had 0.2159. So publicly doubled. So the next thing is to beat this. So 2271, 2159 locally. Nice. Cool. So how can we improve our model? We can improve our model by tuning these parameters, obviously. Also, we can improve our model by choosing superior models. So I'm going to change a little bit of things. So we are going to change this model. We're going to find another model, multilingual. No, you're going to, it's in the model spot. So should they go, or should go the Dazan large? This was trained on This was not trained on African languages at all. So, okay. Let's go to Masakhane. So we have this. This was also trained on African languages. You can try this, but it's gonna take a while before it runs because it's a large model. Let's look for other small ones. So what are we going to use here? No. You can experiment with that later. Let's go with int floats. Even though it was not trained on African languages, let's just try it. Let's just try it. So cool. So we're going to replace the model here. And since we closed our 1DB, we have to like log in again. Then our project name will still remain the same. But remember here, which in our training arguments, we started our model name with this. So when you log into 1DB, let's actually log in. We never logged in. So we're going to see our experiments, how our model was performing. Or another way to improve your model is to train for longer. We only train for like 70 steps. So yeah, you can see how your model is performing, GPU usage, etc. Eval, can create a report. Yeah, explore on your own. But let's restart this. So restart runtime, restart and run all. Yeah, restart and run all. So one way is to improve your models, to train for longer, to change the learning rate, to tune the learning. Runtime disconnected. To tune the learning rates, the weight decay, all that stuff. Yeah. Anyway, it's not. Cool. As we wait for this other model to train, any other question? Oh, also the link to the recording. Yeah, obviously, this will be provided. Are we recording? Yeah, yeah. We were recording. So yeah, it will be provided. Oh, so another thing I want to talk about is, if you go to the starter notebook of that you were given, they are not using sequence classification. So there's a difference. So I'm going to explain this in the simplest way possible, all right? NER, named entity or part of speech tagging, is, so sorry, I have to log into 1DB. Cool. So we'll explain. What I want to explain is we have token classification and we have sequence classification. What the approach we are using today is sequence classification. Sequence classification is you're given a whole sentence or a word. So for example, I am happy. All right. Then you're told to predict the sentiments. So sentiments, positive or neutral. This is what is called sequence classification. You're given a sentence, then you're supposed to predict whether it's which class or which class. Token classification in the same sentence is in I am happy is you break this sentence into parts of speech. So for example, I is a okay. I is it a pronoun or what? I am a so it breaks this down into the tags we have here. What? PD no such file found. Come on. Come on. What is wrong? Git clone does not exist. Why? We just cloned it right now. Oh, sorry. Yeah, for sure, for sure, for sure. That should work. Cool. So I was explaining. So it breaks this sentence into I am happy. Then the labels will be, so for example, if I is a preposition, I don't know what it is. If am is an adjective and happy is a, okay, happy, obviously it's an adjective. So I know happy, it's an, I am. Okay, this English stuff. So yeah, it breaks it down into tokens and parts of speech. So token classification, you can notice the pattern here. So I am happy breaks it down into a list of tokens, then the labels is a list of all possible target columns we have been given. Sequence classification, what is actually what you're using right now. We have a word, for example, in Swahili, we have a word, nimekuja. So nimekuja is actually a verb. So you just try to predict a verb. You're trying to predict a verb, okay? If you want to turn this problem into a token classification, you have to have a deep underlying knowledge of the languages which you have been given, because you want to create sentences, full sentences. See, this is a sentence, and you want to know each and every part of that sentence. So that's token classification, if you want to go through that route. And I think in the starter notebook, that's the approach they are using, token classification. So this is the next step you should research on. I guess these guys are using, I think, based on my intuitions or instincts, because I've tried the sequence classification I've tried it a lot. The best I could get was 0.47. So I think if you go through that route of token classification, where you have a deep underlying knowledge of the mother language, then you construct sentences, because in most languages, obviously punctuation marks, the exclamation mark, each sentence has to end with a punctuation mark, right? So if you put it in that context and you let BAT learn that, I think it's going to, okay, it's just intuitions, assumptions. You just have to experiment with it. I've not yet tried to experiment with that approach because I've been so busy. but I think I will. We still have a long way to go. So put that in mind. You have token classification and sequence classification. There is a much better, okay, we have a much better explain teacher. So let's ask ChatGPT the difference of between, so that you guys can understand difference between token okay, difference between token classification and difference between token classification and sequence classification. So given a word, a sentence, I am happy, explain this in terms of sequence and token classification. Yeah. So tokenized into the following tokens: I am happy, then I pronoun, am verb, happy adjective. Then for sequence classification, given the sentence I'm happy, you predict a sentiment positive. So that's the approach we are using. So yeah, go research about token classification versus sequence classification, implement it in your approaches and see which works better. Cool. With that being said, we are still waiting for a model to train. Let's talk, let's have fun. Let's have fun. So can you go over the starter notebook? Sure. The starter notebook. Wait, which starter notebook? This one which you have created or the other one on GitHub? If it's the other one on GitHub, bro, that's too complex. Too complex. Yeah, I try to go for a much simpler approach, but I think if you wanna fight, because I'm with you guys, if you wanna fight with those top guys up there, I think we should go over that starter notebook, because those guys have been experimenting with these approaches for a while now, the Masakhane group of people. So that pipeline they have set must be one of the keys to such a good score. Yeah, so maybe we'll set, if I go through the starter notebook on GitHub and understand it so well, maybe we'll have another session to go do it. So hopefully. Yeah. Any other questions? Oh, okay. Let's get, as our model trains, let's just get to know each other. So I'm Stephen Kolesh. I never even introduced myself. I'm Stephen Kolesh. I'm from Kenya. I'm not, okay. I'm still a student though, but I'm graduating on November. So I finished my undergraduate on April, but now I'm waiting just to graduate. Yeah, currently I'm an AI engineer at a company called Ngeni Labs. Yeah, that's me. And I go by the name Kolesh GR on Zindi platforms. So anyone who feels like to introduce himself, tell us what you're doing, tell us fun things about you. We're here to have fun. So please.
Okay, my name is Shay.
Yeah.
From Nigeria.
Cool.
And then also a machine learning engineer, really, but just a beginner.
Oh,
So
nice.
I'm assistant from Lagos, Nigeria.
Cool. Nice to know you. Nice to meet you.
Yeah, let's.
Oh, yeah, you're doing ALX?
Yeah, almost done anyway.
Oh, nice. Cool. Anyone else? Don't be shy. I don't bite. You'll be shocked.
Hello, everybody.
Hello.
My name is Shafed Philippe. I'm from Senegal.
Nice to meet you, CDB.
Nice to meet you too. I'm an undergraduate on computer science and statistics.
Wow, amazing.
I'm looking forward to do some competition in machine learning, but it is very difficult to start.
Oh, so you're a complete beginner. You've not even enrolled in any competitions on Zindi?
I'm not a complete beginner, but I never do some. I did never pass on a competition before, but I have some knowledge on start learning and Panda and that.
Oh, nice. This is the right space for you. You should always be joining it. These sessions happen every 2 weeks, or sometimes 3 weeks, but it will always be announced. And we are going to go through currently on Zindi. Thank you, Zindi, so much, because currently there's a lot of active competitions. See, we have a lot. So we can go. Even this was launched like it's just one day. So there's a lot of opportunity for us to learn. The big thing here is for us to learn. Forget about the prizes. The prizes will come, but as long as we learn. So this initiative I started because I was bored. I was bored during the weekends, and I wanted to find something fun to do and with the community. So this is my way of learning from you guys and you learning from me. I'm not an expert. I'm not an expert completely. I will say I'm an intermediate. I'm an intermediate because I participated in a couple of competitions. So yeah, I'll be looking forward to learn from you guys too. And even if you have ideas, please, just shoot it out here. We're going to discuss it, and maybe that is the key for us, like even to compete with those top guys up there. So CDB, this is the best place for you, and welcome. Be sure not to miss others. Cool. Anyone else?
Hello, guys.
Hello.
My name is Ashport Simango.
Nice, Archibald.
Yeah, I just finished my computer science degree in June, so I'm waiting to graduate from the University of Zimbabwe.
Nice. You're actually on the same. I'm even. I'm also waiting to graduate. So like, yeah,
nice.
Cool. Nice to meet you, Archibald.
Nice to meet you too. What were you doing?
I was doing BSc in computer science, bachelor in computer science.
Same.
Nice.
I was actually wondering if we can create a community whereby we can help each other on this particular stuff. I actually joined Zindi on way back in October 2020.
Oh.
I haven't been participating that much due to education, the pressure. But right now I want to get started. Yeah.
No worries. You want us to create a community?
Yeah,
then
something like that.
I'm so bad. I'm so poor at social media. So maybe if one of you wants to volunteer to do that, please feel free and create a community for us to be chatting. So if any one of you wants to volunteer to do that, because I'm so poor at social media things, being active and managing a community. Yeah.
Me too. I'm not that a big fan of social media, but
The thing is,
I started NLP like today. I never did NLP.
Today?
Yeah, today.
It's not. I sent you resources, so you're badly off here.
Yeah. Thanks, man.
Cool, Archibald. Anyone else? Cool, let's go and see how our model is performing. Our new model. Uh, 0.2159. Sorry guys, I just lost connection. So just a minute. Cool, now we are improving. We are at 0.32 accuracy. Should we have a consensus? Should we interrupt it or should we let it train for like another 3 rounds? Should we interrupt it and submit this 0.32, or we should wait for it to get to 50? Right now we are at 20 steps. Should we or should we not?
How long do you think it's going to take?
It's going to, so I think the validation part is taking a lot of time. Okay, let's just wait for this, the 30th step to finish, then we interrupt it, then we call it a day.
Okay.
Then you guys can go and improve it, and there are good resources. Let me link the resources to you. So Hugging Face has tutorials. Hugging Face, yeah, right here in their GitHub. So these are directory called notebooks. They have gone through token classification. They have gone through sequence classifications, and a lot of fun and interesting notebooks. Audio classification. Actually, this notebook, you can use it for this computation. Fine-tuning for audio classification transformers. We have a new challenge that is dropping tomorrow, I guess. Starts in 1 day. Where is it? There was a competition. These. Can you create an ASR recognition model for Swahili? I think you can use. We'll use these files to train your model and submit your sentences. The goal of this competition is to build an ASR model that will help illiterate people use existing apps to find which bus they can take. Yeah. So check this notebook out for tuning for audio classification and transformers. And I guess, is it audio classification really? Or what is it? The goal of this evaluation, let's see. What? Okay. No, it's not audio classification, but you won't lack a notebook that will help you. So I've diverted from the main reasons we are here. There's this notebook right here. It explains to you everything about what you have gone through, but in details. So it will show you everything we have gone through. Then you can look at this. So we have for Hugging Face, we have for TensorFlow, token classification for TensorFlow. Then, yeah, you can have a look at all these notebooks. So let me link this on our charts. Let me link this in our charts. Oh, where will you share the link to this recording? I'll share it in the discussions. I'll share it in the discussion. It will be on YouTube. Yeah, so there's a lot of resources for you guys to learn about NLP. Be sure to research, especially Cargo. Cargo, there's a lot of resources. Also, let's see our models. It's about to finish the third step. So nice. We are at 3281 accuracy. So you can let this run on your free time. Let's interrupt it. Yeah. Then you do just the same things. Damn. So it's going to, oh my goodness. Okay. Let's continue talking because that will last for a while. So there are guys who never even talked. So are they afraid to talk?
Hello.
Hello.
So my name is Abdullahi Bangura.
Nice to meet you, Abdullahi.
Yeah, I'm from Guinea. And
nice to meet you.
Yes, actually my background is not data science. I'm a public health nurse.
Oh.
Here, working at UN Migration Agency.
Nice, amazing.
Yeah, I really love data science, so I'm learning everything by myself.
Wow.
So, yeah, I've taken part to some competition in Zindi, like biomass classification.
What's your name? What's your name on Zindi?
Is a AF Bangura.
AF.
Yeah, AF Bangura.
Oh, yeah. Nice.
So, I've not been doing well, so.
No worries, we are going to improve step by step.
So I'm just data enthusiast and learning, ready to learn new things. Yes. Yes.
Thank you for joining in.
Okay. Thank you.
Cool. Tony hasn't spoken. Tony, do you want to speak? It's okay if you don't. Oh, it's amazing. Cool. Understandable. Uh,
I have a question.
yeah,
Sorry.
cool.
Yeah. Could you explain a little bit the difference between CPU and GPU?
Oh, the difference between CPU and GPU.
Yeah, and why do we use them? So
Oh, so uh, why do you use them? So the difference between a CPU and a GPU, I'm looking for the right words to use. So
okay.
let me think. So GPU allows, what I know why we use GPUs in deep learning is because GPU allows for parallelization. I guess that's the right word. So let's just Google what's the difference between CPU and GPU. Okay, no, that's not the right way to ask. What's the why? So the question is why we use GPU, why we use GPU over CPU. Although there are some technological advancements in CPU right now that allows CPU to be even faster than GPU while training neural networks. But let's answer the first question: why we use GPU over CPU in deep learning. Yeah, so GPUs are optimized for training artificial intelligence and blah, 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 as they can process multiple computations simultaneously. Yeah, that aspect of parallelization helps GPU perform deep learning tasks more faster than CPU. And I guess that's the main reason why you use GPUs because if you try to use CPU on this task, on these task, you last here forever because CPU is slow, very slow. But GPU, because it can handle multiple processes simultaneously, do parallelization, then that's why it is used. But you can find better answers. Or can anyone here give a much better answer than that? Uh, yeah, I'll share the copy of my notebook. Like all this will be available on GitHub. So Abdullah, I hope I have answered your your question a bit.
Yeah. Because I
Yeah,
was thinking it was related to the space and the speed
the
of the
speed.
processing.
Yeah,
Yeah.
actually, it's the speed. Yeah.
Okay. Thank you.
Cool. So we're going to wait for a bit. Going to wait for this to finish in a second. So if you wait for this model to run, since you have already set up the safety measures of having early stopping callback and loading the best model after 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 the training has ended, then you're safe. You're safe to like train this model for until it stops itself, because now based on the patients you have specified, then if you continue running this model for a while, you'll get to the 0.40 range, which I am at currently, because this is basically my full solution. I'm not in my 0.4 models, I've not done anything special. This is what I've used. So yeah, so the best is 0.32816. Let's see how that will translate into the leaderboard. Now we are going to wait for this again. Cool. It's over. So get rid of this. Nice. Oh, download. Yeah, you can see that the validation we are using is actually working. If you had used only train test splits, then you could have suffered a lot. So this notebook, I'll provide this notebook later this day. So yeah, that's pretty it. So thank you guys for joining in. I'm going to end. We could have our WhatsApp group, Telegram, or something like that if you're on my. Cool. Just set it up. Just set it up. Then, do you want us to send us your numbers, our numbers right now? Because I can. So CDB, do you wanna do that or your GitHub link? Oh, cool. Sorry, guys. Sorry. I'll make sure you give me some stars on my GitHub repo. So yeah, I'm going to paste it for you guys. Cool. Let me send you my number. But this is it okay though? Yeah. 254. So you can just set it up if either of these other guys want to join in, they can too. So shout out to everyone who's joined. So proud of you guys. So proud of you guys. We are learning a lot. We have learned a lot. By the way, let me tell you something, guys. I was really struggling with validation, finding the right languages, and I can see these are a beautiful pattern right here. Check this one out. The first one was 2271, and our local validation was 0.22 something, right? This is 0.3346, and the local one is 0.3281, bro. That's this one is amazing. This one is amazing. This correlation is amazing. Seems that we have our lucky languages in our cross validation. So yeah, pretty much it. So cool. Yeah, Abdullah, cool. So let's call it a session. Thank you guys for joining in. Bye. Have you saved the numbers? Because I want to end the meeting now. CDB, you are the one handling that. So
Yeah, I see the two number. I already take it.
oh, cool. Nice. So bye guys, thank you for joining in. This was very fun. We're going to have fun, more fun in future. So be sure to joining in. Cool.
Thank you very much.
Well, welcome. We could have our WhatsApp group. Yeah. Cool. Bye guys.